Okay. So the first thing you want to do is you want to find a zero of the polynomial given to you, and that can be done by looking at the factors of the constant term in your polynomial. So this is the first thing you want to do. अपने constant term के factors list उन factors में से you can go with trial and error and see if any value makes the polynomial equal to zero, and that particular value will be the zero of px. From the zero you can make a factor. That's the first step you want to do. You want to obtain a factor for px. Once you have done that, now remember, just obtaining the factor of px has two steps involved. First one is to list the factors of the constant term, and then second one, from those list of factors you are going to identify the value which is a zero of px. Then you will be able to obtain factor of px. That's your first step. And then afterwards, the factor that you have obtained, you want to carry out the division of your px by that factor to obtain the quotient, and then the quotient will be factorized further. This is what we have done. So simply stating it this way, px is equal to the factor that we obtained in step number 1 multiplied with the quotient obtained in step number 2. But the quotient that we have obtained is a quadratic polynomial. So we are going to see if it can be factorized further. And it's not necessary, you'll have to see for yourself whether or not the given the quadratic quotient that you have obtained in step number 2 will be factorized further or not. So I hope you remember, like, this makes sense to you. Yes, you can use that method also, the one I discussed with you earlier, where you could simply take the terms in pairs and then you could work out with that. This is the one which I discussed. I think that this is the one you're asking. This method generally does not work for all cubic polynomials. This might not work for all cubic polynomials, but this method works for all cubic polynomials. So it will be better because sometimes it is possible to use that pairing thing, but students start with this because that's the thing we make them practice a lot. So if you can identify that your cubic polynomial can be factorized by pairing up the terms and then you'll be able to do it, it's completely fine. But the thing is, you should be able to identify that you have completely factorized the cubic polynomial if you are using that particular way. I suggest you go with this one unless you're 100% sure that you know, yes, that this cubic polynomial, once the terms are paired up, will be factorized into linear factors. All right. So I'm going to take one more part now so that we go over how we have to do this actually properly without writing all these things on the side here. So let's name the polynomial as px. We've got x cubed minus 3x square minus 9x minus 5. And if you can see, if even if we pair up the terms, it won't help in any way. You can pair up in any way. Up 4 terms में से जैसे मर्जी pairs बना लो, it won't help. So I'm going to find out first thing this factor for this polynomial. So first step is to list the factors of the constant term. Constant term is minus 5. So the factors will be positive 1, negative 1, positive 5, and negative 5. And in your book, sometimes it's written this way, plus minus 1 and plus minus 5. You can write this way also. And you're going to try any value out of these which will make the polynomial equal to 0. So I'm going to start by taking x as 1. So let's take x as 1. P1 will be equal to, so this is not equal to 0. Now let's take x equals to minus 1. This makes it equal to 0. Check.
Yes, ma'am.
So this means the value that we have used is a 0 of px. अब यहाँ पे नेसेसरी नहीं है कि आपको 1 से ही स्टार्ट करना था. आप अपना वर्किंग कॉलम में रफ में एक बार ट्राई करके देख सकते हो कि किस वैल्यू से आंसर 0 बनेगा. आप डायरेक्टली वो पुट कर सकते हो. Like you could directly put x equals to -1 instead of starting with x1. And once you have obtained a 0 of px, to convert it into a factor, attach x minus with it. So this thing is easier to remember. Suppose the value of x is -1 and I want to convert it into a linear polynomial. So I will be bringing -1 onto the left hand side. So this is the factor. And now the next step will be to carry out division. If you're writing down, please let me know because I'll need to scroll down so that I can do the division. I would like you to try this division on your own. I mean, like right now, just do it side by side on your copy without looking at the screen. And you can just cross check whether or not your division is correct because you will need practice for this one. Changing the signs. So the division is done. The remainder is 0. That's how I know. Till now, I have been going fine. Now the third step is to factorize the quadratic quotient that you have obtained further if possible. So this is the rule which I'm using here. I'm going to write my dividend as the product of divisor and the quotient, remainder added to that. Remainder, since it's 0, I can ignore that. I've got the divisor as x plus 1 and the quotient obtained is x minus 4x minus, sorry, x square minus 4x minus 5. And I want to factorize this quadratic polynomial further. And if you want, you can do it on a side or you can do it right here. So I can do this here. And this can be factorized by splitting the middle term. And I'll be replacing this with these linear factors that I just obtained. This is your answer. Anyone with any questions? If anyone's writing down, please let me know. Okay, done already. That's great. Shall we take up the next part?
Yes, ma'am.
Yes, ma'am.
I'm not going to write down the steps this time. I'll directly start. So we have factors of constant term as positive negative 1, positive negative 2. Now, I'm just going to do it with trial and error before writing here in the working column and see which value will make the polynomial equal to 0. Obviously, since all the times are having the same sign, positive values will not make your polynomial equal to 0. Positive value से आंसर नहीं आएगा, negative value से आएगा. So try negative values. Try all the negative values. You could start with -1, -1 if substituted will make it -1 plus 13 minus 32 plus 20. I think this helps. So I'm going to take x as -1. So this is how you're going to do it. If anyone has any questions at this point, like we have done now like 3 parts. If anyone wants to ask anything or if you have done it any other way, you can just discuss right now. So I'm going to give you the last part as homework. I would like you to try that on your own. And we'll be starting with the next exercise, which is based on identities. And you have done square identities last year, the identities involving squares of binomials. So I would like you to list the identities first of all. There are, I think, 14, 15 identities as such if we list all of them, but some of them can be generalized from one identity alone. So I'm just going to help you mark it in your book. And if there's any change, we'll just write it there. So please write down all the identities in your copy before starting exercise 2.5. So these are the identities you did last year, the identities involving the products of binomials. The first one is x plus y whole square. Maybe you've done in A and B. If you are comfortable writing the identities using A, B, you can write it that way also. It's just a formula. So you can use A and B if you are comfortable doing that. So x plus y whole square means x plus y multiplied with x plus y. So this is the sum of two terms. Binomial multiplied with binomial, where the binomial contains sum of two terms. And the second one is x minus y whole square, which is again product of the binomial with itself, where the terms are subtracted, x minus y multiplied with x minus y. The expansion for these is given by square of the first term plus square of the second term minus or plus, depending on whether it's addition or subtraction. Sorry, I've said it the wrong way. Whether it's addition or subtraction, you will have plus 2 times the product of terms. And if it is subtraction, you will have minus 2 times the product of the terms. And the squares are both positive. The product term will change sign depending on whether you have addition of the terms in the square or subtraction of the terms in the square. Then the third identity involves difference of two squares. This is actually very important. Difference of two squares, it is given by the sum of terms multiplied with the difference of terms. Then last one is where you have product of two binomials involving first same term and the second term change their signs, and this is how you expand it. You will have square of the common term plus the sum of the non-common terms multiplied with your common term plus the product of non-common terms. Now, if you have learned it this way, fine. I'll be using it or repeating or saying it this way कि जब भी हमारे पास इस तरह का प्रोडक्ट होगा, जब पहली टर्म मैच हो रही है और सेकंड टर्म मैच नहीं हो रही, तो आंसर क्या आएगा? कॉमन टर्म का स्क्वायर आएगा प्लस नॉन कॉमन टर्म्स को ऐड करके कॉमन टर्म से मल्टीप्लाई करना है, प्लस द थर्ड टर्म विल बी ऑब्टेन्ड बाय मल्टीप्लाइंग द नॉन कॉमन टर्म्स विद ईच अदर. And we are supposed to carry the signs. This one's very important for that. Take signs of A and B along with them when you are applying this identity. You can write down careful while using signs. Afterwards, I think we have identities on page number 46. And as you can see, the same identity which just did, like the identity for a square of binomial has been extended to the square of a trinomial. So this here is a trinomial square. And as you can see, result बिल्कुल मिलता जुलता है. So you have square of the first term, square of the second term, square of the third term, plus 2 times you have to take the products in pairs. So 2 times the product of first, second term, plus 2 times product of second, third term, plus twice the product of third and the first term. And this identity can be used in various ways. For example, if you want to change the sign of any of these terms. Suppose trinomial में आपकी middle वाली term negative है. How does this affect your identity? The squares will all be positive. X square plus y square plus z square. Then the terms which contained the product with y will change their sign. So this will affect this term and this term. You will have minus 2xy and minus yz, whereas for the last it's same. जहां पे आपका y आ रहा था. And if we had this, Can anyone help me write the identity for this? Like how will we expand this?
X square plus y square plus z
X
square
square plus
y
z
square
square
plus z square
minus
minus
2xy
minus
minus
2xy
minus
2xy
minus
minus
2yz minus
2xz
2xz
two
minus
zx.
2y.
Okay. Uh, let's see by raising your hands. Please raise your hands. Okay, just one, two, three, four, five. Ayushi.
Yes, ma'am.
Yes, beta, could you answer this one?
Minus 2yz minus 2zx.
Okay, so let us see what will happen here. I told you that these terms which contain negative sign will be affecting their products. So right now, if we take the product of the first two,
Yz will be positive
yes,
in yz.
this will
Plus
be, okay, yeah. Let me just write it in a different way. Janvi and Rohandeep, you have raised your hands. I've seen that. All right. I'll just write it in a different way so that it's easier for the other students to understand how this will be modified. So you have squares positive. जब भी आप expand करोगे, whole square expand करोगे, जो squares आएंगे individual terms के वो हमेशा plus से आएंगे. So x square, y square, z square will be positive irrespective of the signs that x, y, z have with them. उसके बाद आनी है आपकी product terms. 2 का product आना है first 2 के साथ, then double, second, third, then double, third and first. Now see if that helps. पहले आएगा x और फिर आएगा माइनस वाई, फिर आएगा माइनस वाई एंड माइनस जेड, एंड देन यूल हैव माइनस जेड एंड x. Does this help? I think now you'll be able to see how the signs will be changed. So your identity x minus y minus z whole square will actually be x square plus y square plus z square minus 2xy plus
Plus
2yz
2yz
minus
minus
2zx.
2zx.
अगर आपकी टर्म में प्रोडक्ट टर्म में दोनों वेरिएबल्स माइनस साइन वाले आ गए तो उनका प्रोडक्ट पॉजिटिव हो जाएगा. y भी नेगेटिव है, z भी नेगेटिव है, प्रोडक्ट इन दोनों का पॉजिटिव होगा. दैट्स व्हाई दिस टर्म इज पॉजिटिव because this was negative and this was negative. Whereas over here you had positive term multiplied with a negative term. Similarly, in the last one, you had a positive term multiplied with the negative term. So this is how you can expand. यहाँ पे आपकी बुक में सिर्फ एक आइडेंटिटी दी हुई है. You can expand it in various ways depending on what sign each of the terms inside bracket carries. So I'm not going to help you write these on your own. We will be using it although in the questions. And as you can see, उन्होंने दो examples लेके समझाया भी हुआ यहाँ पे. But we will be doing it in the exercise. I'm right now going to just discuss the identities. On the next page, please mark these down because you have to write these in your notebooks. The next we have cubic identities for binomial. You have done x plus y whole square, x minus y whole square. Right now we have x plus y whole cube and x minus y whole cube. Sum of two terms cubed. This is what we have. And how you're going to expand it, you will have cube of the first term plus cube of the second term plus 3 into एक्स वाई. अब ये लग रहा है कि बिल्कुल वैसे ही है जैसे ए स्क्वायर बी स्क्वायर और 2ab होता है, उससे मिलता जुलता है, लेकिन ये एडिशनल टर्म यहाँ पे आ रही है. 2 इज रिप्लेस्ड बाय 3. So you will have x cube plus y cube plus 3xy, but यहाँ पे एक term extra आनी है, the sum of the terms. And if you have the difference of the two terms, अगर आपके पास difference cubed है, x cube minus y cube minus 3xy into x minus y. In some books it's expanded. The last product has been expanded, and if you expand it, this contains square terms. So अगर हम इसको डिस्ट्रीब्यूटिव प्रॉपर्टी अप्लाई करके सिंप्लीफाई कर दें तो आपके पास ये लास्ट टू टर्म्स बन जाती हैं 3x square y plus 3xy square. So sometimes it's given this way. They have they have expanded it in both ways. So these two identities are very important. We will be doing questions on this, applying it to algebraic expressions as well as evaluating cubes of numbers. And then there's the last identity, again, one of very important results. We have, now this is actually quite different from the remaining ones. ये बाकी सभी से काफी different है. We have x cube plus y cube plus z cube minus 3 times xyz, and this expression, अगर आपके पास इस sort का expression है जहां पे आपके पास 3 cubes हैं, you have cube of one value, then cube of second value, then cube of third value, and it is followed by 3 times the product of all of these terms inside the squares. How you can expand it? First of all, you will have the sum of those individual terms, x plus y plus z, without the cubes. तो जिनके क्यूब किए हुए हैं उनको प्लस कर लेना है एक ब्रैकेट में, और दूसरी ब्रैकेट में आपके पास आएगा स्क्वायर ऑफ द फर्स्ट टर्म प्लस स्क्वायर ऑफ द सेकंड टर्म प्लस स्क्वायर ऑफ द थर्ड टर्म माइनस माइनस माइनस. जो प्रोडक्ट्स आएंगे वो साइक्लिक ऑर्डर में आएंगे, first with the second one with the third one with the first one, and each of these products carry minus sign with them, and there is no 2 or 3 here. Please compare all identities and then learn, only then you will be able to like apply it in the questions. इसका एक modified result है which I want you to write down with me right now after you have listed your identity. So I think on one page you can list the identities and then write down a note with the identity number 8. Identity number 8, the one I just mentioned. This is what the identity is. Now just think of this. आपके पास ये स्टैंडर्ड रिजल्ट है एक. अगर इस पूरे एक्सप्रेशन में this particular trinomial is equal to 0, इस trinomial की वैल्यू 0 हो जाए, how would it affect your result? So left hand side
The
is
whole would be 0.
X
That's
cube
correct.
plus y cube plus z cube equal to 3xyz.
That's correct. Taran has actually directly taken us to the conclusion. So this is what will happen अगर आपका trinomial on the right hand side becomes 0. Now 0 multiplied with any value will be equal to 0. So आपकी identity की value हो गई equals to 0. And from here we can conclude that x cube plus y cube plus z cube is equal to 3xyz. The product term has been transposed to the right hand side. Now how this is helpful, I'm going to take up a question just to explain this. It's actually question number 14th of the exercise, and you don't need to write this down as for now. I'm only taking it for reference here. So you have minus 12 cubed plus 7 cubed plus 5 cubed. So we have this as x, this as y, and this as z. Your expression actually is x cube plus y cube plus z cube, where x is taking the value negative 12, y is taking the value 7, and z is taking the value 5. Let me know if this is making sense कि मैंने अपने एक्सप्रेशन को कैसे कंपेयर किया है. मेरे एक्सप्रेशन में 3 क्यूबिक टर्म्स हैं और जिनका क्यूब किया है, जिन नंबर्स का मैंने उन वैल्यूज को x, y, z से रिप्रेजेंट कर दिया. पहले -12 का क्यूब है, -12 को मैंने x लिख दिया, फिर 7 का क्यूब था, 7 को मैंने y लिख दिया, और फिर 5 का क्यूब है तो मैंने 5 को z से रिप्रेजेंट किया है। तो मैं अपनी एक्सप्रेशन को इस तरह से लिख सकती हूँ, एक्स क्यूब प्लस वाई क्यूब प्लस जेड क्यूब, और अगर एक्स वाई जेड की वैल्यूज वापस पुट कर दी जाए तो मेरा क्वेश्चन बन जाएगा। नाउ द स्पेशल थिंग अबाउट दिस एक्सप्रेशन इज, यहाँ पे जो एक्स वाई जेड हैं उनका सम 0 बन रहा है। Am I correct?
Yes, ma'am.
So if you just take x, which is minus 12, and y, which is 7, and z, the answer comes out to be 0. And this is what I had here. And अगर ये चीज थी तो हमने ये कंक्लूड किया था। And that's what I'm going to use here. Now you can use the values of x, y, z in your expression. You will have minus 12 cube plus 7 cube plus 5 cube equals to 3 into minus 12 into 7 into 5. And then you can get your answer. And this is done without calculating the cubes. आई होप यू कैन फॉलो व्हाट आई एम ट्राइंग टू से है कि आइडेंटिटी एज सच जो थी उसको हमने सम में किस तरह से यूज़ करना है। तो अगर आपको ऐसे दिया हुआ है 3 क्यूब दिए हुए हैं और आपको कहा हुआ है कि इसका आंसर निकालो, और आपको क्यूब्स भी कैलकुलेट करने के लिए कहा, द क्वेश्चन सेज के फाइंड द आंसर फॉर दिस एक्सप्रेशन विदाउट एक्चुअली कैलकुलेटिंग द क्यूब्स। सो व्हाट वी डू इज वी ट्राई टू फिगर आउट कि ये एक्सप्रेशन किसी आइडेंटिटी से रिजेंबल करता है कि नहीं करता। तो ये रिजेंबल करता था एक्स क्यूब प्लस वाई क्यूब प्लस जेड क्यूब से, बट एज सच इसकी कोई आइडेंटिटी नहीं है। एक्स क्यूब वाई क्यूब जेड क्यूब सेपरेटली कोई आइडेंटिटी नहीं है, लेकिन हमने एक रिजल्ट कंक्लूड किया था जो मैंने अभी नोट की फॉर्म में आपको लिखवाया है विद द हेल्प ऑफ लास्ट आइडेंटिटी। तो लास्ट आइडेंटिटी से हमने एक कंक्लूजन डिराइव किया था, वो हम यहाँ पे यूज कर सकते हैं कि अगर जिन टर्म्स का क्यूब किया गया है उनका सम 0 बन जाए। So the terms whose cube has been indicated in your question, if their sum is 0, then the expression which contains first term cube plus second term cube plus third term cube will be equal to 3 times the product of these individual terms. That's what I have used here. We will be using this in the question. Now I am going to help you write down 2 more identities which are not indicated as such in the list of identities, but in your exercise they have been given as a question. So if you mark that in your book, I think that will be better. It's question number 9. Question number 9, please write these as identity number 9th and 10th. So after the note, you can list these. And these are used for factorization. और इसकी एप्लीकेशन यहाँ पे होगी in question number 10th. let's start with the questions. Question number 1 is expand using suitable identities. X plus 4 multiplied with x plus 10. So this is your identity x plus a, x plus b. The answer is given by this is something you've done last year also, I guess.
Yes, ma'am.
So be careful when the signs change. This is what I indicated earlier also while we were discussing these. I'm not going to write down the identity the second time because it's the same identity here. So we have square of the common term plus take your non-common terms and add them. So I've got 8 and minus 10 multiplied with the common term, that's x, and then finally the product of the non-common terms with their signs.
Excuse me, ma'am.
Yes.
Ma'am, all the identities are to be used with their signs.
Yes, most of them. If you actually understand identities, जब भी हम apply करते हैं, उन्होंने there are some identities which have been listed directly by carrying their signs. Like for example, x plus y whole square है, और आपके पास next identity है x minus y whole